Alright, so continuing on with section 8.1, the bookwork from page 541. If we look at number 30, the first thing I started with was with the blue here, and if what I saw was that in this triangle here, I knew a leg, and I knew a leg, and the hypotenuse was missing, and so I set up the Pythagorean theorem to figure out what the x was. So that was my first step. My second step that I did was I looked at if this is an altitude, I can use that as the geometric mean. And so there's the square root of 2 and the square root of 2. And then the z and the 3 times the square root of 2. And I could cross multiply. One thing that I do need to end up doing in this step is that rationalizing the denominator again. So I do need to multiply by the square root of 2 over square root of 2 to make sure that I get the radical out of the denominator. And so that's how I found my z. Once I had the z, I had this side and this side. So I had two legs of the triangle, and so therefore I had to use Pythagorean theorem to get the hypotenuse. And that's what I did here in red. If we are looking for number 31, we are told the geometric mean of a number and 4 times the number is 22. So the geometric mean is 22, that goes here. Here's my number that I don't know, x, and 4 times that, 4x. So if I cross multiply, 4x squared is equal to 484, divide by 4, x squared equals 121. And square root both sides, x is going to equal 11. Okay, let me take and move this up. Let's see. Next set of problems here. Looking at number 35, find the values of the variable. So if we look, we have an altitude, and so there's 12 and 12. And then 24 and t plus 1. So I'm going to take and cross multiply here, subtract my 24, and then divide by 24 to get t equals 5. In number 36, there's my altitude, w plus 4, w plus 4, 24 and 6, there we go. Now here when I cross multiply here, I have w times 4 times w times 4. So I'm going to have to FOIL that, and that's going to give me w squared plus 8w plus 16. So if you need to go off to the side and write those steps down, you can. If not, you can do it in your head. 60, and then 6 times 24, 144. Since this turns into a quadratic, I now need to set this equal to 0. So that means I had to subtract 144. And then I had to factor this, so I had to look for what two numbers multiplied to a negative 128 that are going to add to 8, and that is going to be a negative 8 and a 16. If I was solving the quadratic, I would have w equals negative 16 and w equals 8, but for this particular problem, we only want the positive answer. For number 37, altitude problem, so there's 6 and 6, and then m and m plus 5. And so when we cross multiply here, we get m squared plus 5m equals 36, so we get a quadratic to the second power. So I'm going to have to set this equal to 0, which means take 36 over, and then I'm going to have to factor it. And when I factor it, keep in mind that for this particular type of problem, I'm only interested in the positive root. So the positive answer there is m equals 4. In the next set of problems, we are simply just rationalizing the denominator. And if we look at this, I'm going to say that we multiply by a 1. And that 1 takes a different form of whatever the denominator is every time. So here's a square root of 2. We're going to have to multiply by the square root of 2 over the square root of 2. That would give me in the numerator 2 times the square root of 2. In the denominator, that would give me the square root of 4, which is 2. and then the numerator, denominator, those 2's cancel out and leave me with the square root of 2. Here was our original fraction. Here is me rationalizing the denominator, multiplying by the square root of 3 over the square root of 3. This time, nothing cancels out. In number 72, the square root of 4 is 2. I don't need to rationalize the denominator. Keep in mind I cannot divide these two things. This is underneath the radical symbol. This is not. I cannot go any further with that problem. And then we just had a couple more of those types of problems. And so here is, in my denominator, is the square root of 11. So here's me rationalizing it, multiplying by the square root of 11 over the square root of 11. Notice that I get the square root of 55 here, but that does not have any perfect square factors, so I cannot simplify that any further. Here's our original fraction in number 74. Here's me rationalizing the denominator, multiplying by the square root of 3 over the square root of 3. I end up with 21 times the square root of 3. This would be the square root of 9, which is 3. Notice how 21 and 3 are both on the outside of the radical, so I can divide those two things, and my answer is 7 times the square root of 3.